Anyway, but what are they doing with these things 3,000 years ago? It's not fake. We saw it, and we got pictures and all that. We're going to post all this on the website, but it'll be in my talk about what the theoretical explanation is. Anyway, it's about time for the next speaker, which will be Norman Wootan, and he's going to talk about the EV gray motors. Again, thank you for coming to the KeyLinet conference. I think we'll have a good time. Based on what we did last night, it'll be a lot of fun. And just relax and enjoy it. We don't have academics here. You don't see suits and professors and all that. This is working guys, so we're here to share information. I guess that's it for the welcome. Thanks. And this is Norman Wootan, a longtime friend and excellent researcher. He knows, if you want to know about motors, this is the guy to talk to. He's the one that called me up and says, "You're not going to believe what we got 2 years ago." He said, "We got the EV gray motors." And I said, "Norm, don't be pulling my chain." So he said, "I'm swearing." His lab's only like a mile from where I was, so I drove over there. He said, "Bring your camera." So I go over there and I'm like, this is like historical stuff. And so Joe Gordon was over there, and Norm didn't warn me about Joe, or I would have taken the tape recorder, because he tells you all this stuff about gray. He knew gray really close. And so Norm shows me the motors, and I'm just like amazed, and I'm taking photographs, and we scan those in. And then a little while later, when he finally got a chance to open them up, we were able to go inside and show the insides, and I think that helped spark interest. Then, of course, when Peter came up with his thing with the power conversion tube, that's what's led to all this, because right now everybody's wanting power, and if these things are self-running, it could be a big deal. So anyway, this is Norman Wootan. Thanks for speaking, Norman.
What we're going to do on the presentation of the EV gray technology is go into a little historical background behind how we came to find these motors. As for myself, I spent 30 years in Army aviation and career soldier. When I got out, I made my way over here to Dallas in 1981, summer of 81, and got connected with Jerry through the old BBS, and developed a sincere interest in free energy over unity technology. And through the various trips to Colorado Springs to the Tesla conferences and New Energy conferences up in Denver, put on by Hal Fox, I met Ken Hawkins. Ken, where are you? Here he is. Stand up, Ken. This is the man right here that made contact. Joe Gordon, where are you? There he is. Ken met Joe Gordon, and of course Joe Gordon was the attorney for EV Gray and the principal in Western States. That we'll go into the connection behind Z-Tech, EV Gray Enterprises, and Western States. But through Ken's efforts and traveling for 2 weeks with Joe Gordon talking his ears off in a car, they traveled around the country and they located these motors. And one of the prime investors, and keep in mind now the investment money, most of the investment money that was put into the EV Gray technology came from dirt farmers up in Kansas, Nebraska, Montana, Idaho, you name it. And EV Gray was involved in the religious community. He worked out in California for Reverend Deering, feeding himself and family and everything. Joe was, were you best man at his wedding up in Council, Idaho, when he married Starr up in Idaho. So Joe's had a relationship, very close relationship with E.V. Gray himself, and he knows a lot of detail. And after our presentation here, corner Joe out here, and he'll fill you in on a lot of the intricacies on the financial side of this thing. But Ken Hawkins went up to Dodge City, Kansas, and one of the principal investors had these two motors, and there's an alternator unit over here that charged the batteries that's under the table. And we have the repulsion plates there that Tom Valentine, you saw probably the pictures of Tom Valentine catching this magnet that was tossed in the air. We have that repulsor plate. But they found these motors behind fix-it shop or repair shop up in Dodge City, and the man, this was on a Friday, they went up there to look for the motors, and the man said if you hadn't arrived today, these things were going into the scrap metal bin tomorrow. One day, these things would have been history, never to be found. They were going to be scrapped. Fortunately, we recovered them. They had been sitting outside in the weather, and they were in very bad condition. In fact, the big aluminum, I'm going to show you all of the inner details of this motor here in a few minutes. When I opened that big aluminum, that's prototype number 4, built in 1971, it was completely packed inside with field mice nest. And I said, oh, that's the way that thing worked. These mice are running around. Jerry picked at me about that, but it was completely packed with a field mice nest inside of the thing. So to give you an idea of the condition that they were in. In fact, some of the wires still have the chew marks on it where they ate the insulation off the high voltage windings. And I'll show you all of that detail here in a few minutes. But the motors were brought to Dallas. They were entrusted to me to open them up and take a look and see if we could determine if these things were actually over unity. Naturally, we've got the motor, but we don't have the driving circuits. It seems as though the man that had these motors at the shop apparently had one of the driver circuits, and he took it apart because he had beautiful high voltage capacitors, and he's in the repair business, repairing heavy equipment, elevators, electric stuff, and he probably used them for starting capacitors on motors somewhere. So we lost the driving circuit completely. Of course, we make contact with Dr. Lindemann, who is working on the conversion tube driver circuit for these motors. So maybe we can marry what we have up with what Dr. Lindemann has, and we can refurbish one of these motors and get it running. They're in good condition. It's a matter of cleaning them up and redoing the brush contacts and everything in it. Contrary to popular belief, these motors do not have spark gaps in the motors. There's commutation circuits and all in the thing that I'll show you. The actual spark gap and what enable these motors to do what they supposedly would do, perform over unity, this is debatable. I sincerely believe that Gray depicted these motors correctly when he said that the XviD motor placed in an electric car would extend the battery life like 4 times longer. If you had an electric car that would run 100 miles on a freshly charged batteries, his technology would allow this thing to run 400 miles because of the efficiencies of the motors. He never touted these things as being truly over unity. But the tests that were observed by numbers of people that witnessed these things on a dyno and everything, the things would run and the batteries would still be fully charged and they're carrying a load. Now, we've heard stories about these motors that some people that maybe Gray didn't just wanted to discourage because he had a lot of hanger owners. You know, anytime you have something like this, you got every Tom, Dick, and Harry comes along that wants to get involved. Don't have any money, but they're curious. And a lot of people said, you know, they could take and grab the shaft on the motor and stop it. It didn't have any torque. Well, I beg to differ with you because I'm going to show you here in a few minutes that if you have the rotor in either one of these motors turning, if it's only turning 10 RPM, the flywheel on that thing weighs 30 pounds and it'll wring your arm off if you grab the thing. So that's a bunch of hooey that you could stop on with your bare hands. You can't do it. And this big motor over here, they have run them up to 10,000 RPM. And we're talking about some serious horsepower, around 80, 90 horsepower. Puts out some serious torque. Just the sheer weight of the rotor and flywheel combination on there, you're talking about nearly 70 pounds of rotating mass. Without further ado, what I'm going to do is go over here and we're going to start looking at some of the inner workings. And I think they're going to take the video camera and zoom in, and I hope we can put some light on the subject over here. Is this mic, we're able to move this mic, carry it around, and you want me to use the other one? Back in best that we can determine, XviD worked down at the old Cape Canaveral. Remember back in the early days of Sputnik and all? This was back in 1956-57, whenever we got involved in the space program. Russians put the Sputnik up. We had the old Vanguard rocket program. We're talking about liquid hydrogen, oxygen, and all, and everyone we saw on TV was burning up everything, trying to get it off the pad. This is before Werner von Braun over there in Huntsville went down there and showed them how to put a rocket into the sky using solid propellants, because he was involved in the Army Air Defense Systems, and he was involved in solid propellant boosters. And he put the first payload in orbit with the Jupiter C, which is a solid propellant. But in those old days, in the late 50s, E.V. Gray was working as a mechanic electrician down on the Cape. And the story goes that one of his best friends that he worked with down there was a Russian immigrant by the name of Popov. And probably a lot of you have heard of this gentleman. And the inspiration for this technology came directly from Popov, because Popov was a student of Tesla and studied Tesla. And all of this technology has its roots back in what Tesla was doing with the old Pierce Arrow car that he supposedly built up in Buffalo, New York. And I think the stories about the Tesla Pierce Arrow car was the inspiration behind this. And Popov supposedly showed Gray how to get this magnetic repulsion effect, to maximize this effect. And Gray put this in hardware form. Story goes that Gray built the first prototype in 1961 of this motor. It was a small one. Dr. Lindemann told me that it was a small unit, and you have pictures of it. What happened is Gray got all fired up over this technology, realized what he had, so he started running around trying to get investor money. And by 1971, he had rounded up enough investor money that this, what he did, by looking at these motors, you can see that he stamped the number, prototype numbers on each one of his motors that he built. And this motor right here, this aluminum job, was prototype 4, and historically we can trace that this one was built in 1971. And it was a single pole rotor. I'll pick that thing up and show you what it looks like here, and I'll zoom in with the camera and we'll get a close-up of it. But it was a single pole rotor and a 3-pole stator, and it fired every 120 degrees of rotation. And the rotor is massive. The thing weighs about 45 pounds, and it had a 30-pound flywheel on it. And when I tore it down, we find the carbon brushes where they run in the aluminum collector rings. This motor's had many, many hundreds of hours of running time on it. You can see by the carbon tracing and all in the motor that this aluminum prototype was run extensively. Many, many hours of running on this thing. So there's no doubt that these motors ran, and they did exactly what they said they did. Now, I don't know how many of you have heard about the concept car called Fascination. If you go to the McClellan Automotive website on the internet down here in Houston, there's an automotive museum of, past technology and everything. McClellan has a website. You go on there and read about the Fascination car. It was a futuristic concept car, 3-wheeler. It was aerodynamic design and everything. And they started off with a Rankine cycle steam engine in that car when it the concept first came out. Well, Stanley's steamer didn't get anywhere because of the fear you have a wreck or something like that. You got life steam, if you get scalded and all this stuff. So immediately they switched off. They contacted Gray with Gray Technology, and this was in 1973. They wanted to employ the Gray technology in the car, and you can buy the big glossy posters and the promotional literature on this thing, and it was touted in the press and all as being a fuelless engine, and it specified the Gray motor in this Fascination car, this future concept car. And one of the problems that Gray had on this motor right here, the reason it's taken apart It's very difficult to take it apart in the first place because all of these parts are so tightly machined and fitted and everything. I had a hell of a time taking both these motors apart. And if I had them together, it would take 3 people to carry it in here. And I wouldn't be able to handle the parts. And the object of this conference is to show you people the inner workings of this motor. So I took them apart purposely so that you could see the insides. If they were together, it would take us a half a day to take them apart. So I have them apart for you so you can see all of the details. Now, the reason why the motor was built out of Teflon is that the motor completely assembled weighs, with the transmission ready to put it in the car, weighed 320 pounds. They wanted to lighten it. So Greg got the idea on his prototype 5 over there to make it out of Delrin and G10. So they machined that unit over there in around 1973, and it's all made out of Delrin, nylon, G10 phenolic, and even the main shaft in the thing is G10. Well, any machinist in this room will tell you that you'd rather machine 6061 aluminum and steel rather than fool with that stuff. Plus the fact that a piece of Delrin or G10, this piece of material right here is extremely heavy. It's heavier than the aluminum front plate. I'll pick it up here in a minute. And in fact, you'll all get a chance to handle these parts. This piece here is a lot heavier than an aluminum end plate. But his object there was to try to lighten the weight of the motor. But it didn't work because in addition to the weight, you didn't get any weight savings. This material cost about 10 times as much as aluminum. Very expensive. That stuff is not cheap. You go out on the market and buy nylon like this, costs a fortune. As far as the workings of the motor, you have these stator coils. I took this stator coil out of this aluminum motor here to show you what the stators look like. Remember something back in the writings about Tesla? He was talking about coils. If you wanted 2 coils to work together, what you have to do is mass match the coil. Forget about the size of the wire. If you wind one coil with copper wire, let's say, and you take that copper wire and you put it on a scale, you can take any size wire and put it on the balance on the other side and start putting wire on the scale until you got the same mass. Then you got 2 coils that'll work together. And this coil right here is a perfect match as far as mass of the copper in it with the coil that's on the rotor. They're mass matched. This one is wound with about 14 gauge solid copper on this coil. The coil in the rotor, the matching coil, is wound with the same wire. Now, the Teflon unit over here, he used, instead of solid copper, he used 14 gauge, what we call THHN stranded, and it's silver tin. To have the very lowest resistance. So it's silver tin, fine stranded wire. And he's dealing with high voltage, and you understand the skin effect when you're pulsing high voltage. The fine stranded wire, silver tin, was a lot better conductor than the solid copper. So he was making advancements as he went along in this. There's another feature about this rotor and stator coils. If you look at the laminations, this edge of the lamination is thinner than the other side. Whenever this is mounted in the unit, there's a 15-degree skew in this when it's mounted. The rotor, if you back up and look at the coil mounted on the rotor, there's a 15-degree skew on it in the opposite direction. And what happens here is you have a magnetic field whenever the 2 coils are what we call in battery. They're aligned. And you pulse this with a high voltage pulse of DC into this. There's an asymmetrical geometry here of the magnetic field. The way the magnetic field builds you've got an automatic torquing or coming apart like that, although they're perfectly aligned because of the 15-degree skew angle of the lambs, the way they're built. So the magnetic field, when it rapidly builds like that, you got a tremendous amount of thrust or torque that's created. And this single pole rotor right here, with 3 of the stator lambs and 1 on the rotor like that, like I said, this one fired every 120 degrees of rotation. The firing of this, the way the thing is wired, through these brush contacts here in the collector ring, I've got the plate is here somewhere. Here it is right here. This plate right here mounts in the inside of the housing, and this set of brushes here on the rotor ran inside of this ring right here. And what he was doing, to go to the head end of the circuit to trace out how this thing worked, the rotor coils, the current went through, high voltage current went through the rotor coils first, came out through these brushes into the stator, and then returned back to the power supply. On the 3-pole setup here, these were all fired parallel. These are parallel. The combined resistance on these windings right here, 3 coils in parallel, is 1.3 ohms. And this is, like I said, silver tin wire, so you could take the joules that are in the firing caps that he discharged in here through the rotor coils, then through the stators in series. So you got 3 of these in parallel, and then 3 of the stator coils that are in parallel, but the overall circuit is series, parallel series. So what he's doing is he's dumping, I haven't calculated the kilojoules because we're still debating on the final capacitor configuration of how many caps he had in the firing circuit and of what size. Now, Dr. Linneman and I have come to an agreement that these early motors here, he used 2 microfarad, 4,000 volt caps that were made by Mallory that fired these early motors. And then John Bedini has caps that are, what did you say the value was? 5K, 12 microfarad. So he's gone up on the number of kilojoules that you're dissipating into these very low resistant windings. The object of the whole thing goes back to Tesla. If you compress energy in time, let's say if you took 1 kilojoule and you were able to discharge it into a time frame of let's say 1 nanosecond, you're dealing up in the megawatts of effective power because you're compressing energy in time, is what Tesla was telling us. Remember he said that a good capacitive discharge, a stick of dynamite would just be a consumptive breath in comparison to a discharge from a good cap? Well, Tesla was right because you compress energy in time and the effective power that you get out is phenomenal. I have some of the big discharge caps. Phil is back here in the back of the room. He has most of them in his shop out there in Fort Worth. But we recovered these big Sagamos from a linear accelerator lab. And these things are, what, 3.5 kilojoules on at 60,000 volts. And he has the quarters over here where they were smashing quarters down to dime size and everything, using the Z-pinch effect, using these big caps. So the effective energy that you can get in this motor here is all based on what Tesla tried to tell us from back in the 1890s. You compress energy in time and do some phenomenal things. And this is basically what Gray picked up on and said, we'll just build a motor, that does this. But, you get into this, okay, energy's energy. If you take and you're crunching energy into a very small time window like that, it still has to have the input into it, and the energy doesn't come from nowhere. So you have to have a power supply to provide this energy, and it was the trickery that he used in the driving circuit. And Dr. Lindeman's going to go into some of the finer detail on the driving circuit that made this all possible. There's nothing mysterious about these motors. Really nothing. It's just straightforward mechanics. Any one of you could build one of these things. You look at it and write down all the detail. You can go back and copy this and come up with a lot better way to commutate this thing or transfer energy from rotating mass to stator rather than these brushes. I would have used some nice copper slip rings like you use in alternators with some good copper carbon brushes and all in there instead of these soft carbon brushes. There's a lot better ways to do this. The way this whole motor was designed, when I first opened it up and looked, and I said, I could think of 1,000 ways to improve this. But the genius behind this was Gray, Popoff, whoever. That was their design, and we live with it. But if I built one in my machine shop, I would make it a hell of a lot better and a lot easier to build. The secret, as far as I'm concerned, of this motor lies in this little piece right here. And we'll go look at some of the details on this thing. This is the unit that determines the timing, the phase angle of the firing of the rotor in relation to the stator. Whereas this is just like setting the timing on the front end of your engine in your car. You can take the inner part of this unit right here. See, this rotates. There are set screws on the side of this to where you can, and all the timing marks are all marked on here for the timing of this motor. You could even reverse this motor. You could shift the timing far enough and it'll run backwards. But by the design of the motor, the design of the skewed lambs and everything, the way it's built, it was designed to run in one direction, although you could reverse it. It's reversible. In fact, there's markings on here to where you could set it up to run clockwise or counterclockwise. But the way this thing works, the commutation inside of here, there's broad copper contacts in here. The wide copper contact, I don't know whether that camera can pick that up or not. Right there. The rectangular copper in here is the actual firing contact. That's where the energy went into the rotor coils first, then the stator coils back to the power supply. Oh, okay. Now, adjacent to the rectangular contact in there, you'll see the little round brass contacts. Well, whenever this rotated a few degrees out of the firing position, there's contacts in there that I'll show you the wiper that made contact with a common band in here that enable what we call the kickback EMF that comes from a decaying magnetic field. You get a burst of energy in the form of a spike, a decay spike coming out of the collapsing magnetic field in these coils. That energy was captured through those little round brass contacts and sent back through the power supply ultimately to go back to the battery. And Dr. Lindeman's going to explain some of the problems that Gray ran into on trying to charge batteries with spike energy. Very destructive. Very destructive. Coils this size and this motor turning, let's say, up 5,000 to 6,000 RPM, and the way this thing was fired and everything, we're talking about thousands of volts of spike energy coming back, and it's literally tear batteries up. But he did employ contacts in here to capture the kickback spike energy and trying to utilize it to charge the batteries. And that was what this unit right here does. It enables the timing of the motor and to capture that return kickback energy. Various pieces here. This is the rotary brushes and all out of the nylon unit over here. I'll have to hold this plate up because it's all assembled. You'll notice the marks in here where it says counterclockwise and clockwise markings in here in black on this. You could take and rotate this thing and reassemble it in a position to where the motor would run the opposite direction. And Gray had figured somebody might want to run this motor the opposite direction, so he did make a feature in here where you could set it up permanently to run one direction or the other. The nylon unit, here's you can take a picture of this. You have the three stator coils, and I don't know whether the camera can pick up the fact that there's a 15 degree skew built into the stator lambs in here. And if you come up after the presentation here and take a close look at this thing, you'll see that they're mounted and machined. The lambs are machined to where you got the thick side of the lamb and the thin side, so you can give this asymmetrical magnetic flux field on this. And the rotor that went in this unit, this big unit right here, a 3-pole, it's completely obvious whenever you look at this that you've got the, see how thin this lamb is on this side and how thick it is over here? Can you get that on the... And you look at the way he built this thing, it was finely balanced and everything. You could tell he was an aircraft mechanic because everything is safety wired. He safety wired everything because he didn't want bolts flying out of this thing and tearing it up. Even on the other one over here, it's all safety wired. So he was an aircraft machinist and electrician and mechanic. He used the Teflon blocks to mount the stator coils in the housing. The aluminum motor here had the actual motor mounts that he had envisioned to mount this in a chassis with your rubber vibration blocks and everything, actually mounted in a car chassis. On the nylon unit, let's see, the end plate here has mounting points. There's 4 of them right here where the bolt pattern to actually bolt this in a frame or bolt a transmission to the back of this thing. So he had drilled and made provisions to actually mount this, couple this thing up to a transmission. This is the contact unit that runs inside of this, what we call the commutation unit, the timing. What happened was he has copper brushes spring-loaded in here. And to cut down on the degradation of his contacts and to prevent the wear of this unit was filled with marine lubriplate. This thing was completely covered with marine lubriplate, and this thing actually ran around with lubriplate in here to prevent that thing from, the contacts from eating the aluminum up and eating his brass up. But there was no sign of any arcing of any type in this unit. If you take a series spark gap, and the people that run Tesla coils know that you can take a series gap, and basically what you have here is if you're using a spark gap in the conversion tube that Dr. Lindeman's going to show you, and you take this unit right here, rotates around in the firing position, what you do is you shorten the spark gap path with this unit right here when it makes contact, and then you get the breakover and firing. There's no arcing that takes place inside of this at all. The arc occurs in the conversion tube, in the spark gap in the conversion tube. So we couldn't find any evidence in here of any degradation because of arcing and all from high voltage. It all occurred external to the motor. From the patterns of in here in the rings where the carbon brushes ran in this motor, and this one here on the aluminum, I left this one, some of the carbon tracings and all in here. You can look at the wear patterns and you can determine that this motor had many hundreds of hours of running time on the thing based on the amount of carbon that was deposited. I wiped off a lot of it out of here. So I know these prototypes had a lot of running time on them. I'll show you the end plates for this aluminum motor. The commutation on the aluminum motor over here and the Teflon were identical. Everything was identical. The only difference that we had here is he had 3 poles on that rotor, 1 pole on this. So you see only 3 leads coming out of this motor. There's 7 leads coming out of the other one. Because he actually, to get the effective firing, what he had is apparently he had 3 sets of capacitors. And as they would come into firing position, he would fire a set, and then when it rotated around 120 degrees, he'd fire another set of capacitors. It gave time to recharge and recoup the other 2 banks of capacitors, or however many capacitors he had in the firing circuit. All the parts are almost identical between the 2 motors. These are the 6061 aluminum anodized end plate for this aluminum motor. And weight and all, it's almost equal to the G10 over here as far as the weight. So there was no, in my opinion, there's no weight savings in the motor by going to a nylon Teflon G10 motor. So that was all for naught, and it cost him an arm and a leg more to build that than build the aluminum. All the subsequent motors to these 2 prototypes were all 6061 aluminum with steel shafts. Dr. Linneman's got pictures of the bigger motors, the ones that followed this. There were actually, as far as I know, there were 3 more prototypes that were built. Ken has found one of them in a car up in Denver, Colorado, and I believe that unit would be workable. It should have the driver with it. The man, what is Ken? He wants 50 grand for that, right? He won't talk to you unless you got about 50,000. That's what he wants for the car with the motor in it, with a standard transmission. Peanuts. This is the other end plate for the big motor, and he cut that pie-shaped section off here to provide some airflow in here and actually look at with strobe look inside of the motor while it was dynamically see what was going on. You could strobe this thing and stop action. Everything was going on inside of that thing. So that's why he cut this pie-shaped piece off, so he could actually watch it while it was running inside. Next thing we have here is I'm going to pick this thing up and set it right up here. You'll find this rather interesting. This fabled Tom Valentine demonstration that Gray did. This is a repulsor plate, and this thing is wound with heavy gauge copper wire, and we don't know how many turns are on here or the details behind this. But what happened was when early on, Gray was showing investors the repulsive effect from rapidly discharging caps into a winding like this, a tremendous amount of energy. And they have, Dr. Linneman's got the pictures and everything of Tom Valentine catching this magnet that's thrown all the way to the ceiling from firing a small cap into a coil like this and getting that repulsion effect. Unfortunately, you can see the top of this is broken. There was another coil of unknown number of turns of copper that was wound on this piece of Teflon. And it had another plate on here, and this coil wound. And when you put them together, and these coils are 180 degrees out on polarity, and if you took the clip leads and you put on these little leads right here, and you fired the discharge of the cap to where the discharge went through this winding and then through this one in series, you got in a bucking opposing magnetic fields, and since it's a short duration a DC pulse going into this thing would fly off here with tremendous force. The question is, how many turns of wire and everything? Now that I'm getting my shop built and everything, we'll be able to go out there and experimentally turn some wires. I got all the capacitors and power supplies and everything, and we can launch this sucker. And that's coming. And the reason a lot of people say, well, you know, you have these motors, why haven't you tried to run one of them? Well, I'm like Jerry and everyone else. I have to work for a living. And I've been so busy paying bills and working for a living, and it's only very recently that Ken and I went to Berlin, Germany, and spent 8 days, and we negotiated a contract. And thanks to the Germans, we'll have a machine shop and lab to work in. 4,000 square feet of climate-controlled building, completely equipped machine shop, welding, all the technology. And this is under contract that we have, and the offshoot of this is we'll be able to play and do some of the things that we've always wanted to do. So Ken and I probably spent a lot of time out there, and Joe is out here. You might want to talk to him. He has some people that are interested in resurrecting this EV gray technology, and they want to put some money into it. They want to actually see one of these things run and see what it will do. So in the future, we will be working not only on our project, but in our spare time, we're going to be working on this, and there's a number of other projects that we want to work on. Ken's got some pretty far-fetched crystal technology that he wants to work on in the telecommunication industry. And it's going to be rather interesting. This next year is going to be very fruitful. And hopefully, as Jerry pointed out earlier, there's more and more information that's coming to the forefront as people are willing to communicate and relate their experiences and their experiments with one another. We're putting two and two together very rapidly. We already know, based on this technology here, even if it's not over unity, if you can take a motor like this and extend the battery life of an electric car fourfold over what it does right now, that's worth a lot of money. A lot of money, especially in the times that the prices we're paying for energy now. So think about that. We don't have to go over unity to have something that is worthwhile in this energy race that we're in. If we can just vastly improve the efficiency of what we're working with right now, we have something that's worthwhile. But the holy grail that we're after is that true over-unity device. The one that you can bootstrap the thing up and it'll run on its own. The fabled perpetual motion machine. I don't believe that, personally, I'll give you my view on this, having dealt with MRA, Dan was involved in an MRA project. A lot of you in the room probably followed that. We built the MRA, and it tapped what we call the aether, or the space background, or zero-point energy, whatever terminology you want to use. The MRA, I'll stand firm on the fact that MRA worked. It did exactly what Joel and I said it would do. It was over unity. There's one fact that's ironclad about tapping etheric energy. You cannot close the loop. You cannot make the unit run on its own. And it's because of the fact that when you're dragging etheric field or zero-point energy into a circuit, whenever you try to close the loop and make it chase its tail and power itself, it won't do it. Dan's shaking his head there because we talked about this. You cancel the effect. Yeah, he's nodding his head. I thought you were going to sleep. But no, Dan is a serious researcher in this area, and we're in agreement on that. And Tom Bearden has a device called the MEG, which he's using this crystalline ceramic laminations that Allied Signal came up with. That's very efficient. There's very low eddy current losses in the laminations, and Tom built a unit that employs this type of very low loss lambs. It's similar to the MRA the way it works, and he's filed patents and everything else, and hopefully he's going to try closing the loop on that. But Tom told us a long time ago when we were working with the MRA that it's impossible. You can't do it. But he's chasing that right now, trying to close the loop on his MEG device. And personally, I don't think it can be done. You can improve the efficiency all day long with a circuit like this, but you'll never make it sustain and run on its own, because that's not the nature of the beast. Yeah, Dr. Lindemann has some very interesting outlook on this. But hopefully somebody's going to crack that egg and come up with something that's workable. But it's very difficult. Yeah, you can't do it directly. You can't take a solid-state electrical circuit like that and close the loop and say, okay, this thing's going to run itself. You have to have a media to go through. Like John Bedini used lead-acid batteries or batteries. The electrolyte is the media that he uses. And it's the rattling of the ions in solution in the electrolyte is the key to what John Bedini's doing. I built a Bedini motor way back when Tom Bearden was working with Bedini, and Bearden was writing about it in his books. Fortunately, when I moved to Dallas in 1981, summer of 81, the Tesla bookstore was right over here in Greenville, Texas. Dan worked over at E-Systems over there, Greenville. And all you can do is walk into the Tesla bookstore over here, and all the latest Bearden stuff was on the shelf. I drove over there. I was talking to Tom Bearden and buying Bearden books over at Greenville before I ever met Jerry Decker and got on the BBS. So I was really fascinated with all this, Excalibur briefing, all of Tom Bearden's theories, about tapping the 0 point and all of this. Star Wars Now and all of this stuff. So it goes way back. So there's a very colorful past on this whole free energy thing. And Jerry goes back and he's researching John Worrell's Keeley from 1890 back in Philadelphia. And he's had great difficulty. Dale Pond spent his whole life researching that and trying to chase out all of the details behind Keeley. And they were fairly successful in gathering all this information up. And here we're dealing with a man that lived in our decade and supposedly died in about 92 out there in around Reno, Nevada out there. And darn, it's been this dog-eat-dog trying to dig out information on this guy, and we're talking about in the last 10 years. And it's really difficult. And if it hadn't have been for Ken running into Joe Gordon and knowing the investors, all 2,200 investors that were invested in this, to the tune of like $28 million in this EV gray technology. And this is dirt farmer money. One of the dirt farmers led us to these motors because he was a principal investor, and he wound up with these things and gave them to a doggone repair shop in Dodge City. And that's how we wound up with them. But, it has been, Ken went out to Van Nuys out there and was doing work at the sheriff's department, wasn't it, Ken? You were working out there for a long time and asked hundreds of questions, people out there, and no one even knew E.V. Gray. And there was no trace of him ever living out there, ever having a driver's license. There's no death certificate on the man. We don't know the real detail on how he died. Supposedly he died of acute lead poisoning from being shot, and the other story is he had a heart attack. Someone broke into his mobile home. He got excited 2 o'clock in the morning, dropped dead from heart attack. He's a big burly man, chain smoker, and chased women. And supposedly someone broke into a mobile home there in a little town right across the Nevada and the California line, and in a mobile home park there, and supposedly he dropped dead of a heart attack. But there's no death certificate on the man. We do know he was buried in Sparks, Nevada. And Patrick Gray was going out there with an investigator trying to sort out the details behind his father's death. And unfortunately, Patrick didn't show up or couldn't show today to give you first-hand information as to what really happened to E.V. Gray. We don't know. We don't know the true circumstances. I need a little help here. I'm going to show you one other piece that we recovered here. I'd like to see that thing turned over and a big piece flung in the air. Where better over here here another way. Okay, what XviD did is, Dr. Lindeman's going to go into some detail on this. The destructive kickback spike energy coming out of collapsing magnetic fields. It's a horrendous voltage and situation you're trying to deal with. They capture this energy to charge batteries. And Gray worked with McCullough, built a special battery that had very thick plates, special dielectrics and everything, and he figured the battery would survive the destructive forces. But what he did is he decided to go to an alternator, rectify the output of this, and this was belt driven off of there's a little sheave, or pulley you want to call it. If you're a country boy, you call it a pulley, and I call it a sheave. Went on the end of the main motor shaft like that, and there was a belt drive that drove this alternator. He had just a simple field wrist out on here, so he could adjust the field current on this thing. And that way he could take and rectify this, and he was using this to charge the batteries. But that was his version of, in fact, it's got the tag on the end. This is R&D 2 on the tag on the end of it here. But that was the dynamo or alternator he was using to charge the batteries after he decided that the spike energy wasn't doing the job or was too destructive. But Dr. Lindeman's going to go into the details on this, on what happened and why he went to this. Any question? I know there's a million questions, Dan. There's a mic right there. Turn your. Okay, you're hot now.
Okay, two questions there, Norm. One was you said you think could be reversed. Do you think the efficiency was any different going clockwise versus counterclockwise because of the cant and the magnetic field?
Absolutely. The skew, 15-degree skew angles that were built in here, you had an natural asymmetrical magnetic flux field. And the thing was designed to run preferably in one direction. What was interesting about this motor is these shafts are perfectly symmetrical. You look at this thing from above, every hole drilled in this shaft and every feature, you could take this shaft and turn around in this motor. So he had some ideas about, the preferential direction of rotation. You're absolutely right. It had a preferred direction based on the design.
Okay, one other question was the plastic version versus the aluminum version. Do you think he might have gone to that because there was some kind of magnetic problems with the aluminum, or do you think it was just trying to save weight, or what?
Well, there's a couple theories floating around. Anytime you take a very powerful magnetic flux field, what you have in effect is a closed turn, a single turn conductor, and you got a magnetic field in. What do you have? You got a tremendous current that's built in this closed conductor. That's the nature of the beast when you're dealing with a magnetic flux. Over here, good observation. Over here, you don't have a closed conductive path to generate heat. If you go back and look at the dodo ring, how the dodo ring worked, it worked on differential heat in a very low resistant conductor, and you heat one end of the copper band and cool the other end, and you get the current flow. And we're talking about in a copper band that's 12 inches wide and an inch thick, and the thing's 6 feet long in a closed band. You're talking about 40,000 amps, because if you take and look at the millivolts that's developed on the two ends of this copper band and do your math, E equals IR, you got about 30,000 amps flowing. And you could probably get a tremendous heating effect. He's developing a very powerful magnetic field, rotating field in here. You definitely have a problem. Right. Any other questions? Say again? If there's no further questions, that's all I have. And Dr. Lindeman's going to follow me. And he'll enlighten you on the driver side of this circuit. There's one other thing that I was going to tell you about. I met face-to-face with one of the major investors in this that traveled extensively with EV Gray when he was going around promoting this. And the one thing that he was emphatic about EV Gray and his eccentric nature, he was very paranoid. He said whenever he went into a motel room and he opened his briefcase in the room, this man traveled with him, he said laying right on the top of his briefcase was a .38 caliber revolver, loaded, ready to go. The next thing under that revolver was the documentation and everything, whatever he's going to present. You raise that up, and under there was the spark gap conversion tube. He never left that out of his sight. He always took it out of the circuit and put it in his briefcase. And that's a fact, because the man that traveled with EV said that he never let anyone see the details on the conversion tube and spark gaps. The spark gap never stayed in the circuit whenever it was left unattended. That's all I have. Thank you.
We're going to do a 10-minute break. Come back in 10 minutes. We'll start with people. Everybody knows Norman Wootan. He did a great job yesterday. He's going to do even more today. He's going to sing and dance. This is Norman Wootan. Come on up.
Well, today the name of the game is workshops, right? That's okay. We can leave them there. My definition of a workshop is hands-on, and we're going to try to get as many of you as possible involved in examining these motors up here, and you can ask any question you want, because we're here to share knowledge and try to understand how these EV Gray motors work. And some of you people out there might have a little engineering background and may help us out in thoroughly understanding how these things work. I have a fluke meter over here, and we've got the parts laid out, so you feel free to come up here and measure whatever you want, and photograph, feel, touchy-feely, do anything you want with these parts. Ultimately, with the help of Peter Lindemann and his driver circuit and trying to resolve how the driver circuit worked, we'll probably get one of this 3-pole rotor unit over here, the Teflon unit, get it up, revive it, and run it, and do a little dynamometer work with it, see if it actually put out what Gray said it did. But that's long-range plans. It may take a year or so to do all of this. But the key to the whole thing, to revive this technology, is to understand the driver. Any one of you in the room can come up here and look at this motor and say, well, with a good machine shop, I could copy this thing exactly. And there's no trick to that. This is pretty straightforward stuff. The driving circuit is the key, and the conversion tube spark gap. Everything that we have looked into as far as the over-unity phenomena, free energy, the spark gap seems to be the key. To translate etheric energy into a circuit, some circuits don't use spark gaps, but they use pulse energy. And somehow the pulses are the key to entraining, that's what we like to call it, entraining etheric energy into the circuit. Let's see how we're going to proceed here on this. What I'll do is go over here and point out some of the features on the motor, since we're working with a workshop. Yesterday, now I got my hands free since we have this little old wireless mic, so we can be better able to handle this stuff. The very first part of the motor that we encounter is this variable timing ring where you can actually adjust the timing just like you do on the crankshaft of your car. You can go down and put your timing light down there and rotate the distributor and advance and retard your timing. This is what this job did right here. This is the first point of entry of the power into the motor. You can see right here we've got 7 leads going in here. We've got 3 leads that sent the power into the coils. So he fired it. Oh, it's better down there? Okay. Bye. Since you have a 3-pole rotor, 3-pole stator, what he was doing is he had 3 sets of capacitors, and every 120 degrees of rotation, you would discharge a capacitor whenever this wiper contact right here would bridge between a common, we call a common band in here, aluminum band, and these firing contacts. You can see the firing contacts right here, the broad copper. As this wiper wiped past this firing contact, the capacitor discharge would come from the conversion tube spark gap that was in the driving circuit, pulse through this. It went through this wiper ring over here. You see this unit here? This transferred the energy from this unit into the rotating rotor. So you have to have a way to commutate that energy from there, get it from a fixed stator over into the rotor. And you have these 3 little copper cables right here. We're tied onto this little insulated post. There's a screw here that goes down through this. This screwed down through the shaft. You have one right here. You can see the thing is still in there. I took this one out of the aluminum shaft so you could see how he did this. That's the little insulated post. What he did was that from this wiper ring right here, you're getting the energy down into the shaft. Actually, this wiper over here is mounted out here. So what you're doing is sending the pulse into the core of the shaft. There's a conductor in here. This screws into a copper bar in here. The energy goes through the shaft, comes up in here, goes through the windings in the rotor, comes back out into this ring here. The reason it comes out onto this set of brushes is because you have this plate is mounted in the end of the stator housing. You got to get that pulse so you can have a series connection between the rotor and stator coils. The energy comes into this common band right here, goes through all 3 of the stator coils in a parallel configuration and return back to the power supply. So it was a parallel. You've got parallel coils. You got parallel coils in the stator, but they're wired in series. The way the energy comes through the commutation, into the core of the shaft, and into the coils, out of the coils, here, through the stator coils, back to the power supply. And the reason why you do this is so that when you fire, let's say, a microsecond burst of energy out of a capacitor bank, let's say you have 4,000 volts at 2 microfarads, you could calculate how many kilojoules you have, whether it's even a kilojoule. But what you're doing is trying to compress energy and time, as Tesla pointed out. The magnetic flux that's generated with dissipating a capacitor, a discharge into a very, very low resistance configuration like this, that burst of energy is the same thing that Gray was demonstrating whenever he took that thrust plate and would throw the magnet into the air. You get a tremendous burst of magnetic flux. And that's what caused the rotation, the asymmetrical mounting of this, and the timing would vary the amount of thrust, determine the amount of torque that you would get. The magnetic thrust is translated into rotary torque. Torque times RPM divided by 33,000 per minute, or 550 per second, determines horsepower. That's a direct calculation of horsepower. So it's a matter of just putting a dyno on this thing and determining how many horsepower. The claims are that this thing running, I think Peter said that at 3,600 RPM or something, that this thing put out about 90 horsepower on the later versions of this. There was rumors that people that went in, investors or whatever, people that Gray, wasn't pleased that they were there. All he had to do is take the timing and retard this thing like that, and you go over there and say, well, this thing doesn't have any torque. Well, you could show off just about anything you wanted. You could take the timing on this and make this motor run backwards, because it's an electric motor and it had that feature. It has the timing marks right here that you can go behind top dead center, forward and top dead center, and you can make the thing run backwards. But it had a preferential direction or rotation because of the skewing angle, the 15-degree angle that was machined into these parts. Are there any questions on how the energy was commutated into the motor, the path it goes through, and back out to the power supply? Anyone have any questions on that aspect of it? Yeah, anytime you want to talk, just come up and use the mic. That way that John can get it on the recorder.
Okay. I just have a question about, have you made any measurements or made any estimations of the timing of the pulse? Is it in milliseconds? Is it in microseconds? Yeah. And any idea about the strength of the field, the duration, and so forth of the pulse?
See, what we would actually have to do is we can do some calculations like Peter was saying there. Whenever you can dissipate a capacitive discharge, by the voltage you put on a capacitor. Like I have those little photoflash capacitors over there. They are 2,000 volt, 2 microfarad. It's a simple calculation. You can calculate the joules of energy. A joule is a watt second. If you have one joule, it's a watt second of power. But if you take and dissipate this thing into 1 microsecond, what do you have? You've got 6, move that figure over 6 decimal places. A micro is a million. So you take and multiply that joule becomes a million joules. A million watt seconds. It's not really a watt second anymore. It's a fraction of a second. But the effect you get on creating a instantaneous magnetic field is the same as a million joules, because it's a multiplication. And Tesla pointed this out very early that, as I said yesterday, Tesla defined the discharge of a capacitor. He said it's a stick of dynamite going off is just a consumptive breath compared to a good capacitive discharge, because you're compressing energy in time, and time is the key to this. The quicker you can dissipate the energy of the capacitor through these windings and create a torque effect, that's what you're looking for. And that's why the resistance of these windings are so low, and they're wound with you can look at this, come up and look at this wire. That's 14 gauge solid copper that he wound that. We can probably calculate how many turns without having to tear this thing up. We know the resistance of copper wire per foot, and we can measure this coil with the fluke meter there and say, okay, it's so many ohms, and we could calculate roughly the length of the winding in this coil. Just simple calculation. Yes, sir.
Do we have any idea on how we started the motor from 0 and getting it up to 3,600 RPM? Because the timing would be affected as you were starting, and the timing would be off as it were going slower.
Yeah, as Conehead pointed out on his motor there, you can take and set the timing on this thing from a starting position.
Okay.
There's a lot of industrial motors, brush-type motors, that in the past, you used to see them all the time, that to start the thing, roll off and get the thing going, they could take and retard the timing on the thing, and the motor would sit there and roll off and start building RPM, and when it would hit a threshold to where you were starting to get the maximum torque in the motor, they could take and advance the timing on the thing and set the timing to where it was most efficient at a particular target RPM where you wanted to operate the motor. And this is what Gray was doing here. He could take this thing and put it in a starting position, roll the motor off and get it going, and do like Conehead was talking about. His motors perform better whenever you take and retard the timing on it, start it, build it up, and then advance it, and then they really perform
Right, so basically you just get it started, roll the motor over, and then you time it in.
It's like a three-phase, a big three-phase motor. If you hook a three-phase motor up to a single-phase line with two hot, like 240 volts on a three-phase motor, two legs, the thing won't start. It'll just sit there and lock rotor just sits there and hums.
Right.
But you can take a sheave, like on a starting sheave on a lawnmower, and you can wind a rope around the thing and go whop like that, and that thing will just, it'll spool right up and run on single-phase line.
Okay.
And that's how rotary converters work in the shop. If you want to make three-phase power out of single-phase, all you have is a pony motor that's sitting out there. It doesn't even, it's not hooked to anything. It's just sitting there idling, and it'll make three-phase power, but you have to start it. It won't self-start.
Okay.
Yeah.
Thank you.
Peter.
Yeah, I just wanted to relay another thing that Bedini said, that when he saw the machine work, that Gray actually started this thing with a starter motor. Because the impulses coming into these things were so powerful that with the flywheel and everything else, the standing inertia of these things was too much. These impulses coming through were so strong that it would tear the machine apart if he tried to start it without getting it up to about 1,000 RPM before he started kicking these things in.
Yeah, I agree with what Peter is just describing, because you want to come up here and describe the weight of this flywheel to the audience.
20, 25 pounds.
At least.
Considerable.
And you can imagine with this at rest, this field rotor over here weighs about maybe 35 pounds, and you throw a flywheel on here, and this thing is sitting dead still, and you fired that coil like that, it would just go, ugh. It would take, it would do some damage, because there's a tremendous amount of torque effect and all from the magnetic field, and I could see where they would want to roll the thing off and get it up to speed and then apply the power. But it's real interesting that he had all of this timing features and everything to where you can maximize the performance of the motor on the fly by adjusting the timing. Is there any of the features in here that you want me to further describe? Because it's pretty, like I said, the motor's pretty well straightforward. It's just some little tricky things that he did in the design of the rotor, and also the stator coils, like I was showing you. The thick lambs on one side, you can see the thickness of the lambs here, and over on this side it's thin. And you do this so that you can actually physically shape the magnetic field that this thing creates. And you have an opposite configuration here, thick side over here, thin side here, and when you match the two up like this, when they're one right over the other in a firing position, you'll get the torque effect. And I'm trying to slip apart, because it's a 15-degree skew angle that the coils are physically mounted in the unit. They were actually machined that way at an offset. That's a thick, thin. So you get the asymmetrical thrust from the magnetic field. And that's the only trickery that we saw whenever we opened this thing up. That's the first thing that hit your eye, because when you're looking in the motor as you're disassembling it, you look and said, well, that rotor coil is offset. It's not in the center line of the shaft, and that's the first thing you see when you look in this motor. Whoa, wait a minute, now why did he do that? And then it becomes obvious, because you got the thick side of the lamb, thin side of the lamb. And that created that effect that he was looking for. So that was the only thing that's unusual about the rotor stator. And if you want to write down information, the 3-coil configuration, you can come up here and measure it yourself with the fluke meter. This is 1.3 ohms when the windings are parallel like this. And the coils in the stator are wired in parallel configuration, and they're identical, 1.3 ohms. And as far as we can determine, the winding on this stator coil is a mirror image of the winding that's on the rotor. They're identical, and everything about this winding is identical to this. And it goes back to something that Tesla was talking about on designing 2 coils that would work together like in a Tesla coil, a primary and secondary. And he had advocated a mass balance. In other words, if you took a primary that was like 4-aught copper wire or cable, and you made a 2-turn primary, you could take that primary and put it on a scale and get your secondary wire, maybe 18 gauge or 14 gauge, whatever, and just start reeling off wire and put it on the scale. When the balance balanced, those 2 coils would work together. Over in Fort Worth, the guys that are building Tesla coils, Wild Bill's over here, and Phil and Bert Poole have the Fort Worth Tesla coil group. They started looking at some of the coils that Tesla built and everything. When you analyze the big coil out in Colorado Springs, that didn't seem to be true. And some of the coils that they built that puts out like 14-foot arcs, the weight of the copper in secondary primary, there's not a match like Tesla was talking about. It's not a mass balance. But they advocated a mass balance between these windings. Equal weight of actual material, conductive material in the rotor stator coils. That's what he had advocated. And this appears in this motor. So maybe there was something to that. Now there's some wild speculation out there that I heard yesterday that these motors were wound with, special wire. Well, you can come up here and if you want to, I've got shrink wrap that I can repair this, but you can scrape this, and this is solid copper, 14 gauge solid copper. This other motor over here, the Teflon version, you look at the stator coils, you can come up here and look at the rotor coils. This wire is 14 gauge copper, but it's stranded, fine stranded wire that is silver tinned. It's silver tinned wire. And you get the picture of the wire right here? And I've scraped off the insulation off this, determined it is 14 gauge silver tinned wire. And maybe he was wound this motor with that type of wire because remember back when Tesla was working with coils and all, and he'd use Litz wire and everything because it's a small wire, but it's multiple conductor. And each conductor is insulated, has its own insulation. So what you're doing is you're getting the skin effect, and apparently it maximizes the amount of energy whenever you're transferring high voltage and doing work with high voltage. The skin, it travels on the surface. It doesn't travel in the copper wire, it travels on the surface of the wire. So maybe the fine silver tin wire would give you more surface, and you could dissipate the energy quicker when you're working with high voltage. The difference between this motor and the one that Conehead was running up here yesterday, his little motor's back here, is he sticks with the 12 volts driving. And the reason he doesn't like the high voltage, like Peter was talking about yesterday, if you pulse this rotor stator in a parallel series configuration and you dissipate a bank of capacitors into this thing at 3,000 volts, and later versions he was probably using a lot higher voltage in it, maybe 5,000 volts. But whenever you pulse this thing at high voltage, what does the inductive kick look like, the spike? If Conehead over there can create a 1,000 volt inductive kick pulse with a 12 volt input into a coil, can you imagine the magnitude of the inductive spike coming out of a coil that's been pulsed with, let's say, 3,000 volts at several kilojoules? That inductive spike is on the order of maybe 100,000 volts, at least that much. People are familiar with how your automotive ignition systems work, capacitive discharge ignition systems. You take a a 12-volt input. It's at high amperage, and they're using MOSFETs to fire these things to run your car. You're getting like a 60 kV spark coming out of that thing at 1 amp at the spark plug. Racing engines use a 1 amp 60 kV for racing because they're high compression engines and everything else. Your car probably uses about 30,000 volts at probably a 1/4 amp at the spark plug. But where that amps comes from is compression of energy in time. It's not like you could run the thing for a full minute with 1 amp at 30 kV. That's a lot of energy. You're talking about 30 kilowatts. It doesn't get, it's compression of energy in time. Question, sir? You know, come up and use the mic.
I'm not a trained technician in electricity, so I can only relate to when I studied the program from under creative science. They were saying that it requires 6,000 volts and 47 microfarads for the capacitor banks. How is that compared to what Gray was using here for capacitor banks and the microfarads quantity?
In the writings that we have on these two motors, they were using 2 microfarads, 4,000 volt Mallory capacitors on this to fire it. Now, yeah, 3 of them. So this is what Peter's been able to glean from whatever information's left from this project. And then later, like John Bedini said, that they were 5 kV at 12 microfarad capacitors that they were using in this device. In 1982? That's a... So he graduated up to bigger capacitors, much more energy. And from the pictures that you had up yesterday of the motor, he said it was version 6. This aluminum unit here, the single pole, and the big aluminum housing over here, it's stamped on the end. Fortunately, Gray stamped on the end. All of the parts are marked, what prototype version they were. And the motor that Peter had up there yesterday on that projector, if you look at they can show you the difference in this. It's readily seen when you compare that motor. He'll put it up there and you'll see. Count the nylon buttons on this thing right here. On this housing. These 3 buttons right here that you see where these buttons were right here, those 3, those are the mount for the stator coil. The stator coil goes through those holes, and they're held in there with phenolic pins, and over the top he put these little nylon caps on the bolt heads. If you look at that motor over there, count the number of pins that come out of the housing. That's the ends of these bolts. So what he did on that motor there, that motor was physically about 3 inches or 4 inches longer than this motor. And the stator coils were probably another bolt width longer, because there's a 4th bolt on here. So this stator coil was much longer, so he was going for more torque and more horsepower on that version up there. This has 3 holes, that one has 4. It's not. That's prototype 6. So that's 2 more down the line from this one. So that was identified as 6. Well, actually, this Teflon unit over here is number 5. This is 4, that's 5, that's 6. This is the next one in the line on the production type motors. How many capacitors did you identify down here? Was it 3? So what he was doing is using one per 120 degrees of rotation on your commutation. He would fire one of those capacitors, 120 degrees, fire another one, and your power supply is recouping the energy in the capacitors and getting them ready for the next turn around in the firing order. And so he was bang, 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 come back around, firing them again.
What's that timing when it comes to discharge the capacitor?
Say again?
Discharge the capacitor, is that 3 times per cycle or?
The capacitor, the question was, is the discharge of the capacitors, how many times
Per cycle.
if you take and fire a capacitor every 120 degrees, each capacitor only had to fire one time per rotation, one time. So if that thing was turning 3,600 RPM, the charging rate of your power supply that's charging these things, good question. How much current and what type of power supply would you have to recoup a cap of that size at that rate, 3,600 RPM? That determines your power supply size. And the energy has to come from the battery, and then the energy has to be put back in the battery, or the whole thing would quit.
Norm, I'm pointing up here on the thing here. Basically what we're seeing now is that this capacitor would, let's say, fire at 0 degrees and trigger the first of the electroradiant tubes that would feed into and fire all the coils in the motor at once. Mm-hmm. Then it would advance 120 degrees, and then the number 2 capacitor would fire the second tube that would kick it again while this one's starting to recover. Then at 240 degrees, the third capacitor you can see back there is going to fire the third tube and fire all 6 coils again in series parallel.
That's right.
And then when it gets around to 0 again, it fires the next one. So that's apparently how it ran.
That's right, yeah. It's important that you understand that all 3 poles of the rotor and stator all fired together in parallel, just wham. So you're generating magnetic flux, north pole flux, on both the rotor and stator, and north to north you get the repulsion. So it was a pure repulsion effect, magnetic repulsion.
The other thing I wanted to say is that because of the energy gain in the tubes here, he was not discharging these capacitors from top to bottom. He was stripping a top charge off of these things. So the recovery was not, charging these things from 0 back up to full. That was one of his main energy gain mechanisms, because all he had to do to create, and by the way, there's a delay effect, and he talks about this, is that when the capacitor fires, there's a few microsecond delay before the impulse comes out of the tube. And because the impulse doesn't come out of the tube until the electroradiant event is over. And then all of a sudden the charge that's sitting on those surfaces notices, oh, there's a path to ground. Yes. There go.
What's interesting, what he was pointing out about this electroradiant event that's occurring in the tube, whenever you read Jerry Vasilalo's book, Secrets of Cold War Technology, he gets into this, describes what Tesla was doing back in 1892-93 time frame, whenever he got away from AC in all of his coils, and he built the magnetic disruptor coil that created this etheric fire, crown of etheric fire, which is on the cover of your book and on your videotape. You have this beautiful crown of etheric fire coming off this magnetic disruptor that Tesla built. And in that book, Tesla specified this very narrow rest period. Whenever you create a DC unidirectional pulse, which was done in this conversion tube, this spark gap, when it jumps, bam, and then there's a rest period, and Tesla specified 0.0062 microsecond rest period. And this is where the etheric energy just goes boom. And that's what went into the circuit to drive this thing. It's the etheric input into the thing. And it wasn't necessarily the pulse from the capacitor. The pulse from the capacitor through the conversion tube is what created the event that drove the motor.
Also, you can get an idea of how many amps is coming through here. When you figure that the that each of these things is an open path that are in parallel. And your magnetic flux is going to be ampere turns in this situation. And he's got amps to burn because he's running all this stuff parallel.
That's right.
He's got so many amps in this thing.
If I guess somebody that was really sharp, an electrical engineer, could sit down and study this and probably calculate the kilogauss magnetic flux that this thing created by this configuration. But the unknown here is that electroradiant event, the amount of work that cold electricity will do. This is unknown because no one's been able to work with this type of energy. Cold electricity, as it was described, you could dissipate that energy through that coil, and the oil coil wouldn't get above ambient. Actually, it would get colder. It wouldn't get hot at all. Although you're dissipating a lot of energy through a copper winding, it would stand to reason that the thing would get hot. But not necessarily so when you're dealing with this type of electricity. Another thing that, the Tom Valentine demonstration, this form of electricity doesn't shock you. And Tesla gets into this, and he was talking about the frequency, the repetitive rate. And everyone said, oh, well, Tesla proved that anything above 2 kilohertz, that the human nervous system can't respond, and you can't feel or don't get a shock from anything above 2 kilohertz. And that's why Tesla was able to do this. But this is a different animal. This type of electricity, this cold electricity, created by the radiant event in this conversion tube, was a form of electrical energy that's totally unknown to us, and it even had biological effects that were very beneficial, because it equates to the very life force that runs our bodies, the life force itself. And this is closely akin to this. It's a natural form of electrical energy that's pervasive everywhere, even down at the cell level in our bodies. But what you're doing is you're creating this event, artificially creating this, you could call it a life force. I'm sure every plant, tree, and everything else, and us included, have this life force energy. But this type of form of energy, Tesla had experimented with it to where in the very low frequency you could create physical pain, and it really hurt. Then when you got into the higher frequencies, it would create light effects, various colors of light and everything, and when you got on up higher in frequency, then you got the beneficial health effects from it. And he described it as a pretty silver white flame. It's flame-like, and it was silver white, and that was a characteristic of the radiant event, that you knew you had that final product you were looking for, is by the color, the silver white arc. And that seems to be what everyone is looking for right now, being able to create this radiant event.
I just had an observation on the picture. Has it ever been considered that his prototype has 9 stator coils according to the bolts on the outside there?
Yes. Peter had pointed that out yesterday, because to maximize the amount of torque and horsepower this thing would create, he went and reconfigured the stator coils in here, made them slimmer, he narrowed them and made them longer,
and put more,
and put 9 in there instead of 3.
Okay.
That's what the patent's all about.
Yeah. The patent, if you go to the patent and read the patent, it shows clearly in the drawings 9 stator coils, 3 rotor coils. Yes, sir. You're right.
So it'd be a different timing ring on the end to actually.
The timing is the same. It's over here. What you're doing is you're adding more contacts in here for commutation, because what you're doing is you're firing the thing at different points here. Instead of firing every 120 degrees, since you have 9 coils, then the geometry changes. So you're recommutating it at a different firing rate.
Every 40 degrees.
Yeah. Every 40
Could
degrees.
it be possible that he was firing 3 coils at the same time, 40 degrees off?
Yeah. In the stator, you would have 3 matched with 3 and the rotor
Right.
firing.
Right, okay.
Then the rotor would rotate 40 degrees, and you would fire another set of three.
Three, okay.
Three. So every 40 degrees you had a pulse.
Right.
What it amounted to is, if you take a one-cylinder engine and try to drive something, you get the boom, 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 boom.
Yeah.
If you take an 8-cylinder engine, it's smooth. That's why you can drive a 12-cylinder Jag out here and it's like an electric motor. Very smooth on your torque output, because the pulses, the flywheel's supposed to dampen all this stuff out.
Right.
But the more cylinders you have, the smoother you run, the more torque you can generate.
So this configuration is actually in his patent? But they're not, okay.
This configuration is in the patent drawings, yes.
Okay, thank you.
The coil stator configuration is in the patent drawings, but there's a lot in the patent that is not the way it is.
That's right.
So there's a lot in the motor patent that's not the way it is.
Like Peter pointed out yesterday, the patent is good to protect your idea, but you don't necessarily have to put everything in the patent that you know, because you don't want someone to pick up your patent and go to China over there and start shipping them to Walmart and beat you at your own game. So what you do is you put just enough in the patent to cover the idea and protect it, and don't show all your whole cards. And Gray kept a lot of this stuff hidden. It's not in the patent. Yes, sir.
You mentioned earlier, pointed out that on prototype 4, you know, he had the steel aluminum casing and shaft, and then prototype 5 he went to this Delrin or Teflon, and then it appears on prototype 6 he went back to the steel. Did he find out that the EMI or the RF interference was just too high?
What we're assuming is just about the time that we go from version 4, which is 1971, to 5, which is 73, this is where the Fascination concept car came into the picture. And the Fascination concept car, the first ads that hit the street and the press and everything, it was powered by a Rankine cycle steam engine. Well, steam and automotive don't mix. Remember Buick Wildcat in 1960, I think 66 through 68? They experimented with a V8 engine that didn't have a conventional cooling system. All automotive engineers knew that if you operated a internal combustion engine, a V8 engine or any engine, at around 250 degrees, you could maximize the efficiency of combustion and everything in that engine if you operated the block at about 250 degrees. And your aluminum pistons and everything would still survive. Buick built a Wildcat engine in a Wildcat car, V8, and you can look in the automotive history. It's in the books. You can go look at it. The engine was steam cooled. What they had in the block, on the cylinder walls, in the cast iron block, they had nozzles that sprayed water onto the cylinder barrels. It would flash the steam. Anyone that knows anything about thermodynamics and steam physics knows that to flash water, to phase change of water from liquid to steam, will extract more heat energy instantly than you surround it with water, because it's a phase change phenomenon. The radiator on the car had thick tubes in it, and it was a condenser. And the engine was cooled by steam-cooled engine, and they could operate a Buick Wildcat engine up to about 275 degrees, 280 degrees, because it was steam-cooled. The radiator was nothing but a condenser. But the safety people said, oh God, if we get in a wreck and you burst the radiator and you got this steam out there and somebody's going to get scalded. So that put a stop to the Wildcat. Let me tell you something now. Every one of you are driving a car out there with a 13-pound radiator cap. 13 PSI. Well, anyone who knows anything about hot water, you take 13 PSI and that engine is designed to run at about 220 degrees. 220 degrees, because what they're trying to do is increase the fuel mileage. The hotter you can run the engine, the more efficient it is. You run at 220 degrees, 13 PSI, you have a wreck, pop the radiator, and you got a cloud of steam just goes whoosh into the air like this. Here you go. They're just violating their own rules. Now, you want to see something funny, it happened. It's not funny. A friend of mine, we were flying in the military. We were flying a King Air, and we were out over Kansas, and we were taking off back at Aberdeen, Maryland, and he had this big old thermos bottle, and it was one that had the big glass deal in it. He fills this thing with hot coffee, puts it up on the console. We're flying along. We're over Kansas out there, and we're at about 12,000 feet. And you know a cup of coffee? Oh, yeah, that's a good idea. He takes this thermos bottle, and when he starts to unscrew the lid off of it, instead of the lid, just the cap unscrewing, what happened is the retaining nut on that plastic thermos bottle, it broke loose there, okay? When he picked up like this, the glass envelope was coming up like that, and it pulled the whole top right off like this, 180 degrees at 12,000 feet. The whole cockpit filled with coffee steam, just whoom like this. This stuff goes down through the console, all the radios and everything. We had coffee running down through there. But the windshield in the aircraft up here inside was dripping with coffee because this stuff flashed instantly to steam and scared the hell out of me. And we had, what in the world? Peter, what are you doing? Well, I've never seen that before. But, you know, this is what can happen whenever you take hot water and you're at altitude. Let's say you're in Denver, Colorado, and your car's running at 220 degrees, you have a wreck, you're going to have steam. Believe me. Any other questions we have here? I know you guys have a lot of questions. But, you know, what we're all striving for is efficiency in the automotive applications. And this is what Gray was trying to do.
So how long is it going to be?
To do what?
Get them together.
Well, my shop is being built as we speak, okay? And if on another 60 days, we'll have a first-class machine shop up and running and everything. And I got some other stuff I have to work on first. But ultimately, whenever Peter says, okay, we got all this figured out on the driving circuit, we're going to get together and everything, and we're going to make, this is the one I want to run, is the 3-pole right here. And at least get it running so we can report back to you, you know, what we find here, whether this thing is over unity or not. We don't know.
What kind of power supply are you going to do?
We'll build a power supply similar to that with the radiant, the conversion tubes, the radiant event. We're going to attempt to do what he did up there, but it's going to take maybe a year or so to do this. We have to make, you know, we have to make a living while we're doing this.
Right. Well, those y'all want to chip in and support. Pass the hat. Norman, I want to ask you to do something.
Okay.
This is slightly off topic, but we had a really fun discussion about it with our buddy Dennis Lee. Norman, when ITS, International Testing Society, was going, Norman spent tons of money and built all these really great machines to a Van de Graaff generator, all kinds of stuff, gave it free to the Tesla Society for their museum. Of course, they went broke. Dennis Lee bought it out for $5,000 at the bankruptcy court. Now, at the moment, he's hyping this free energy machine, you know, 1.6 million people, you give $100, you get videotapes and $1,000 input. If you look at that motor very closely, tell him, Norm.
Okay, what Dennis Lee did is he went to the Tesla Museum, and Steve Ellswick's still probably around here, testify to the fact that when in 1994 I went up there, we were working on an MRA project, I took a pickup truck load of stuff out of my shop. I had a Van de Graaff generator, a beautiful thing, stood about this tall, you know, big old, real neat. They had this big old Wimshurst machine. I had two versions of the Adams motor. I had a big old Tesla coil that fired 180 degrees out of phase and did all kind of weird shit. Tore up my computer, running in the living room. But this Wimshurst machine, I had taken 26-inch lucite disc and built this Wimshurst and everything, and I was playing with it because I was interested in electrostatics. Built this thing, gave it to the museum and everything, and Dennis Lee comes along and buys everything. $5,000, he got everything. He got Bill Wysock's coil that was donated up there, the whole works. All the experiments. So he comes out with this thing, this device, and here's his version of the Statica, the Swiss Statica, the Braum machine. And here he is touting this doggone thing, and it's my Wimshurst. The thing will generate about maybe 300 kV electrostatic. It'll jump about maybe 8 inches or so, sparks that it'll make like that. But I built it on a lark because I wanted to play with electrostatic. Here's Dennis now running around hooking people, you know, for the investor money, using the darn Wimsurst that I donated to the museum. Somebody got some use out of it.
You want to say something? I was looking for Mr. London, but Dr. London, I couldn't find him.
He was
sitting there.
Yeah.
You want to say something about tomorrow real quick?
What?
Something about tomorrow.
Ask a question in the mic.
I was talking to Norm. Someone asked a question about getting this financed. Actually, this is a public company, and I have a debt to Jerry Decker that I can never repay in money. The man has done a tremendous favor. But as soon as tomorrow morning, allegedly, I'm a lawyer, I'm going to use the word allegedly, we have got seed capital ready to launch this thing, and we have an enormous amount of work. It's a public company, and I've got to do tremendous amounts of legal work to get it back in a tradable status.
You know, I wanted you to know that Joe Gordon here was the man that enabled us to find these motors to begin with, because he was the attorney to E.V. Gray and knew E.V. Gray. I worked with him and everything, traveled with him, and he had firsthand knowledge. He knows all of the investors that invested, what was it, 28 million total, something like that?
About $28 million, and that figure comes from the FBI, not me.
You know, there were a lot of people, very influential people out on the West Coast. Was it Bill Haber was the one, kind of the kingpin of the
Bill
West
Haber
Coast?
was the kingpin, and Bill Haber was also the thing that caused us the ultimate most problems, too.
What happened is whenever Joe could probably describe it since he's attorney, what kind of legal wranglings you can get into whenever Western States, which was his company, absorbed Z-Tech, E.V. Gray Enterprises, and you suddenly go from just a few investors in a privately held corporation to 2,200 investors, 28 million, and all of a sudden you're doing this one company absorbing another, and SEC said, whoa!
Well, actually what happened real quickly, Haber had set this up as a Cayman Island. The English don't have corporations, a limited partnership. We're based on the English common law. We got a lot from French and Roman law too, including corporations. But they were collecting money and putting it in the Cayman Islands, which of course you can't collect money in the United States unless you are registered with the Securities Exchange Commission. And I had a public company. I had an oil company. I'm oil field trash. I worked for Gulf Oil Company, and I thought I was set for life, but guess who died first? Gulf's gone, and I'm still here. And I bought my own oil company. Western States was a man in Wichita Falls had it, and I bought it. And it was a public company. And in order to correct this overseas thing, Ed merged with Western States, which did correct it. Nobody was ever indicted. That satisfied the SEC, but there was a lot more haranguing and trouble that before we ever got it quieted down. But anyway, we're not ready to accept any investments yet until we get this thing back in a proper public status with the SEC. They're my friends, and I want to keep them that way.
Yeah, you don't want to cross them because
they're as bad as IRS. So you all know those guys. The SEC is no different. I want to keep them on my side, and I'm planning on within the next month, if everything works out tomorrow. There's Dr. Linderman. I couldn't find him. With Dr. Linderman and Norm and I in Fort Worth, I'm planning on getting this thing set up and in operation within the next 30 days. Mr. Marsh has talked about helping me, and we're going to hit the road running and try to get all the legal niches smoothed out just as quickly as we possibly can. And again, I want to thank Jerry. It could not have happened without Jerry. God bless him.
Thank you, Joe. Now, there's another little aspect of this that you readily pops into your mind. E.V. Gray has 4 kids. 4 kids are still living. And there's a thing, I guess, in the law and everything, what are they entitled to? And whenever you start reviving this technology, it was their dad's property. And legally, they would probably have recourse through the courts and everything to come back and enter this picture and everything. So we have to have due consideration to the family. And that's only fair. And this is something that enters the picture that we have to deal with.
The kids own Ed Gray's children, Patrick and Edwin Jr. and James and Mark and the 2 girls own 4 million shares of stock in Western States.
So they have shares now.
Yeah, they have 4 million shares of stock in Western States.
Good. So they'll be taken care of in the scheme of whatever happens. They have to be considered because they're direct heirs to E.V. Gray. Mm-hmm. Anyone have any other questions? Because I think we might be running short on time here. Yes, sir. Okay.
Oh, I can sit down? Okay.
Better to go.
Sorry about that. What right does someone have to build this motor? Since is there still a patent on the motor, and what is the right for someone to build on their own?
Okay, patents and rights. All of the patents except one have expired. The only patent that is still current is on the conversion tube that Peter was showing yesterday up here. That patent on the conversion tube is still in effect and good. And it's the only one. The others are too old. They've passed the time limit and everything. Now, about going back and maybe repatenting aspects of this motor, that's something that a patent attorney would have to go through and sort out and see how many patents have come behind this that would overlay this thing and prevent us from doing that. Something will be done along this line here to probably repatent some of it maybe. We don't know. We don't know at this point. Okay. Well, without further ado, we're going to turn this over to the next workshop and everything. We appreciate your kind attendance and attention. Thank you. Thank you. Okay.
I was so about to do this.
Brings to the Tesla conferences and new energy conferences up in Denver, put on by Hal Fox. I met Ken Hawkins. Ken, where are you? There he is. Stand up, Ken. This is the man right here that made contact. Joe Gordon, where are you? There he is. Ken met Joe Gordon, and of course Joe Gordon was the attorney for E.V. Gray and the principal in Western States. That we'll go into the connection behind Z-Tech, E.V. Gray Enterprises, and Western States. But through Ken's efforts and traveling for 2 weeks with Joe Gordon talking his ears off in a car, they traveled around the country and they located these motors. And one of the prime investors, and keep in mind now the investment money, most of the investment money that was put into the E.V. Gray technology came from dirt farmers up in Kansas, Nebraska, Montana, Idaho, you name it. And E.V. Gray was involved in the religious community. He worked out in California for Reverend Deering, feeding himself and family and everything. Joe was, were you best man at his wedding up in Council, Idaho, when he married Star up in Idaho. So Joe's had a relationship, very close relationship with E.V. Gray himself, and he knows a lot of detail. And after our presentation here, corner Joe out here, and he'll fill you in on a lot of the intricacies on the financial side of this thing. But Ken Hawkins went up to Dodge City, Kansas, and one of the principal investors had these two motors, and there's an alternator unit over here that charged the batteries that's under the table. And we have the repulsion plates there that Tom Valentine, you saw probably the pictures of Tom Valentine catching this magnet that was tossed in the air. We have that repulsor plate. But they found these motors behind a fix-it shop or repair shop up in Dodge City, and the man, this is on a Friday, they went up there to look for the motors, and the man said if you hadn't arrived today, these things were going into the scrap metal bin tomorrow. One day, these things would have been history, never to be found. They were going to be scrapped. Fortunately, we recovered them. They had been sitting outside in the weather, and they were in very bad condition. In fact, a big aluminum, I'm going to show you all of the inner details of this motor here in a few minutes. When I opened that big aluminum, that's prototype number 4, built in 1971. It was completely packed inside with field mice nest. And I said, oh, that's the way that thing worked. These mice are running around. Jerry picked at me about that, but it was completely packed with a field mice nest inside of the thing. So to give you an idea of the condition that they were in. In fact, some of the wires still have the chew marks on it where they ate the insulation off the hot on it. And when I tore it down, we find the carbon brushes where they run in the aluminum collector rings. This motor's had many, many hundreds of hours of running time on it. You can see by the carbon tracing and all in the motor that this aluminum prototype was run extensively. Many, many hours of running on this thing. So there's no doubt that these motors ran and they did exactly what they said they did. Now, I don't know how many of you have heard about the concept car called Fascination. If you go to the McClellan Automotive website on the internet down here in Houston, there's an automotive museum of past technology and everything. McClellan has a website. You can go on there and read about the Fascination car. It was a futuristic concept car, 3-wheeler. It was aerodynamic design and everything. And they started off with a Rankine cycle steam engine in that car when the concept first came out. Well, Stanley's steamer didn't get anywhere because of the fear you have a wreck or something like that. You got life steam, if you get scalded and all this stuff. So immediately they switched off. They contacted Gray with Gray Technology, and this was in 1973. They wanted to employ the Gray technology in the car, and you can buy the big glossy posters and the promotional literature on this thing, and it was touted in the press and all as being a fuelless engine, and it specified the Gray motor in this Fascination car, this future concept car. And one of the problems that Gray had on this motor right here, the reason it's taken apart, it's very difficult to take it apart in the first place because all of these parts are so tightly machined and fitted and everything. I had a hell of a time taking both these motors apart. And if I had them together, it would take 3 people to carry it in here. And I wouldn't be able to handle the parts. And the object of this conference is to show you people the inner workings of this motor. So I took them apart purposely so that you could see the insides. If they were together, it would take us half a day to take them apart. So I have them apart for you so you can see all of the details. Now, the reason why the motor was built out of Teflon is that the motor completely assembled weighs, with the transmission ready to put it in the car, weighed 320 pounds. They wanted to lighten it. So Gray got the idea on his prototype 5 over there to make it out of Delrin and G10. So they machined that unit over there in around 1973, and it's all made out of Delrin, nylon, G10 phenolic, and even the main shaft in the thing is G10. Well, any machinist in this room will tell you that you'd rather machine 6061 aluminum and steel rather than fool with that stuff. Plus the fact that a piece of Delrin are high voltage windings. And I'll show you all of that detail here in a few minutes. But the motors were brought to Dallas. They were entrusted to me to open them up and take a look and see if we could determine if these things were actually over unity. Naturally, we've got the motor, but we don't have the driving circuits. It seems as though the man that had these motors at the shop apparently had one of the driver circuits, and he took it apart because he had beautiful high voltage capacitors, and he's in the repair business, repairing heavy equipment, elevators, electric stuff, and he probably used them for starting capacitors on motors somewhere. So we lost the driving circuit completely. Of course, we make contact with Dr. Lindemann, who's working on the conversion tube driver circuit for these motors. So maybe we can marry what we have up with what Dr. Lindemann has, and we can refurbish one of these motors and get it running. They're in good condition. It's a matter of cleaning them up and redoing the brush contacts and everything in it. Contrary to popular belief, these motors do not have spark gaps in the motors. There's commutation circuits and all in the thing that I'll show you. The actual spark gap and what enable these motors to do what they supposedly would do, perform over unity, this is debatable. I sincerely believe that Gray depicted these motors correctly when he said that the EV Gray motor placed in an electric car would extend the battery life like 4 times longer. If you had an electric car that would run 100 miles on a freshly charged batteries, his technology would allow this thing to run 400 miles because of the efficiencies of the motors. He never touted these things as being truly over unity. But the tests that were observed by numbers of people that witnessed these things on a dyno and everything, the things would run and the batteries would still be fully charged and they're carrying a load. Now, we've heard stories about these motors that some people that maybe Gray just wanted to discourage because he had a lot of hanger owners. You know, anytime you have something like this, you got every Tom, Dick, and Harry comes along that wants to get involved. Don't have any money, but they're curious. And a lot of people said, you know, they could take and grab the shaft on the motor and stop it. It didn't have any torque. Well, I beg to differ with you because I'm going to show you here in a few minutes that if you have the rotor in either one of these motors turning, if it's only turning 10 RPM, the flywheel on that thing weighs 30 pounds and it'll wring your arm off if you grab the thing. So that's a bunch of hooey that you could stop on with your bare hands. You can't do it. And this big motor over here, they have run them up to 10,000 RPM. And we're talking about some serious horsepower, around 80, 90 horsepower. Puts out some serious torque. Just the sheer weight of the rotor and flywheel combination on there, you're talking about nearly 70 pounds of rotating mass. Without further ado, what I'm going to do is go over here and we're going to start looking at some of the inner workings. And I think they're going to take the video camera and zoom in, and I hope we can put some light on the subject over here. Is this mic, we're able to move this mic, carry it around, and you want me to use the other one? Back in best that we can determine, E.V. Gray worked down at the old Cape Canaveral. Remember back in the early days of Sputnik and all, this was back in 1956-57, whenever we got involved in the space program. Russians put the Sputnik up. We had the old Vanguard rocket program. We're talking about liquid hydrogen, oxygen and all, and everyone we saw on TV was burning up everything, trying to get it off the pad. This is before Werner von Braun over there in Huntsville went down there and showed them how to put a rocket into the sky using solid propellants, because he was involved in the Army air defense systems And he was involved in solid propellant boosters. And he put the first payload in orbit with the Jupiter C, which is a solid propellant. But in those old days, in the late 50s, E.V. Gray was working as a mechanic electrician down on the Cape. And the story goes that one of his best friends that he worked with down there was a Russian immigrant by the name of Popov. And probably a lot of you have heard of this gentleman. And the inspiration for this technology came directly from Popov, because Popov was a student of Tesla and studied Tesla. And all of this technology has its roots back in what Tesla was doing with the old Pierce Arrow car that he supposedly built up in Buffalo, New York. And I think the stories about the Tesla Pierce Arrow car was the inspiration behind this. And Popov supposedly showed Gray how to get this magnetic repulsion effect, to maximize this effect. And Gray put this in hardware form. Story goes that Gray built the first prototype in 1961 of this motor. It was a small one. Dr. Lindemann told me that it was a small unit, and you have pictures of it. What happened is Gray got all fired up over this technology, realized what he had, so he started running around trying to get investor money. And by 1971, he had rounded up enough investor money that this, what he did, by looking at these motors, you can see that he stamped the number, prototype numbers on each one of his motors that he built. And this motor right here, this aluminum job, was prototype 4, and historically we can trace that this one was built in 1971. And it was a single pole rotor. I'll pick that thing up and show you what it looks like here, and I'll zoom in with the camera and we'll get a close-up of it. But it was a single pole rotor and a 3-pole stator, and it fired every 120 degrees of rotation. And the rotor is massive. The thing weighs about 45 pounds, and it had a 30-pound flywheel.
Anyway, but what are they doing with these things 3,000 years ago? It's not fake. We saw it, and we got pictures and all that. We're going to post all this on the website, but it'll be in my talk about what the theoretical explanation is. Anyway, it's about time for the next speaker, which will be Norman Wootan, and he's going to talk about the E.V. Gray motors. Again, thank you for coming to the KeyLinet conference. I think we'll have a good time. Based on what we did last night, it'll be a lot of fun. And just relax and enjoy it. We don't have academics here. You don't see suits and professors and all that. This is working guys, so we're here to share information. I guess that's it for the welcome. Thanks. And this is Norman Wootan, a longtime friend and excellent researcher. He knows, if you want to know about motors, this is the guy to talk to. He's the one that called me up and says, "You're not going to believe what we got 2 years ago." He said, "We got the E.V. Gray motors." And I said, "Norm, don't be pulling my chain." He said, "I'm swearing." His lab's only like a mile from where I was, so I drove over there. He said, "Bring your camera." So I go over there, and I'm like, this is like historical stuff. And so Joe Gordon was over there, and Norm didn't warn me about Joe, but or I would have taken the tape recorder, because he tells you all this stuff about Gray. He knew Gray really close. And so Norm shows me the motors, and I'm just like amazed, and I'm taking photographs, and we scan those in. And then a little while later, when he finally got a chance to open them up, we were able to go inside and show the insides, and I think that helped spark interest. Then, of course, when Peter came up with his thing with the power conversion tube, that's what's led to all this, because right now everybody's wanting power, and if these things are self-running, it could be a big deal. So anyway, this is Norman Wootan. Thanks for speaking, Norman.
What we're going to do on the presentation of the EV Gray technology is go into a little historical background behind how we came to find these motors. As for myself, I spent 30 years in Army aviation and career soldier. When I got out, I made my way over here to Dallas in 1981, summer of 81, and got connected with Jerry through the old BBS, and developed a sincere interest in free energy over unity technology. And through the various trips to Colorado Springs,